In this last example, we want to find the sum of the infinite geometric series given by this sigma notation right here. And right away, this should kind of indicate that this is an infinite series since we are taking the terms from the first term all the way up to the infinite number of terms, adding those all up. So this is the key infinite series indicator or red flag. So what we should do is we should kind of scrutinize this a little bit and at first be a little suspicious. Well, if I'm adding up an infinite number of terms, will this actually have a limiting sum? Will this actually converge? Or is this going to explode and I'm not going to be able to actually find what the sum is? So we really need to identify what that common ratio is. And in this case, this is 4 over 5 to the k power. So really if I were to kind of separate this out, I could rewrite this as 4 times 1 over 5 to the k power, or I can rewrite this as 4 times 1/5 to the k power. And hopefully we're seeing that as I'm rewriting things like this base 1/5, that's what my actual r is. That is my common ratio. So since this is less than 1, we could say that this is that the sum converges. So check, that's good. Now, if this was a little bit confusing how I kind of came about that, remember what you can always do is you can list out what the first couple of terms are and just check. So why don't we just do that for the sake of clarity. The first term, I'll list out the first term, the second term, and the third term of this series. So what I'll do here is I will plug in 1 for k, so this becomes 4 over 5 to the first power, or just 4/5. The second term in this series would be 4 over 25, since that's 5 squared, and then plus 4 over, and then 5 to the third power, which is 125. And we could check this. We could divide 4 over 25 by 4/5 and just find our common ratio that way. So this is going to be equal to 4/25 times 5/4, which is equal to 1/5, and there's our r. We can get there a different way too. So what we've identified is the r. Now the only other piece that we need in our equation, let me write down that equation. The infinite series is going to equal u sub 1 over 1 minus r. So we have the r, we just need u sub 1, which we got over here. So this is going to equal 4/5 times 1 minus, what did I say r was? 1/5. So this is going to equal 4/5, 4/5 all over 1 minus 1/5, which is 4/5. And so it turns out this is actually all equal to 1. So if I were to spend the rest of my days infinitely long adding up the terms of this series, it's going to approach 1. So we say it converges to 1. So how about that? Kind of interesting. Why don't you try this last example here, pause the video, give this one a shot. All right, and here's my solution to the problem here. Once I found my first term and my common ratio, I was able to plug it into the formula and come out with an answer of -1/3 for that infinite sum.